Hey, hi everyone, welcome to my YouTube channel. My name is Sunny Savita, and I'm back with another exciting and useful video. Guys, I was talking about a different retrieval system inside the RAG. In the previous video itself, I discussed the first retrieval system that was the contextual compressor retriever. If you don't know about it, definitely you can go and check out with my previous video. So first of all, let me introduce the syllabus, the complete syllabus which I have created with respect to this retrieval system, okay, with respect to this retrieval technique. So here guys, you can see I kept like couple of important retrieval technique which will help you a lot whenever you are going to create any kind of RAG system and the architecture. So the first technique, basically contextual compressor retriever, which I already implemented as I told you. The second technique is self query retriever, which we are going to discuss in today's session, guys. Yes, then a parent document retrieval, sentence window search, auto merging and all. So yes, definitely in the upcoming videos we're gonna discuss this all the remaining retrieval technique. So yeah, stay tuned with me. Please subscribe the channel. If you haven't subscribed, you will get like important and useful topic like this with respect to generative AI and all. So first of all, let me show you my YouTube channel, guys. There I started this particular series, this advanced RAG, and like I already recorded 8 video, and this retrieval, guys, it's a part of this advanced RAG series only. And before this retrieval, basically I have discussed about the re-ranking and all. So if you will start from here, from this particular video, this powerful RAG using hybrid search, keyword plus vector, you will get the complete agenda, right? What is this vector search, hybrid search, okay, what is this re-ranking and all, everything basically I try to cover now, based on the like different messages, and behalf of so many student and all, I'm covering this retrieval part as well. And yes, the first video is out, definitely you can check out. You will learn a lot, it is my guarantee to you. Now coming to the topic, so first of all, guys, let me introduce the agenda, the complete agenda with respect to this self query retrieval. So this particular video I divided into three main sections, so I can write over here. The first one is, first I will show you the basic RAG flow. What is this basic RAG flow along with the code and all. Then after this basic RAG flow, we'll discuss the theory of what? Theory of the self query retrieval. Theory of self query retriever. SQR means what? Self query retriever. The third point, practical of the self query retrieval. So yes, we'll see the practical also, how you can implement this self query retriever. Now let's start with the first part of the video, basic RAG flow. So within a 5 minute I will wrap up this thing, because it is very much important to understand the further thing, the further concepts and all. So let's say we have a data, we can collect the data from the variety of the sources. Then we are doing chunking and all. After the chunking, what we can do, we can create an embedding. Why embedding is required? So that we can store inside the vector database and we can perform the similarity search, right? Now after the similarity search, guys, this retrieval comes, means we are performing similarity search based on the query and this document which I have stored inside the database. And then whatever document will be the highest similar one, okay, so those particular document I will retrieve, and this particular process is called retrieval. Now we have different approaches for retrieving this data, because this basic search, actually this basic similarity search, semantic search, it does not work. Similarity search, you can say similarity search or semantic search, both are same, okay. Now this basic similarity search, actually it does not work like with so many conditions and all. And we want some advanced technique with that, actually we can retrieve useful information, so that further I can feed it to my LLM. Now this re-ranking, I already discussed a couple of technique of the re-ranking. The most important one, definitely you can check out. Now I'm on this particular part, okay. So, guys, the very first one, the very first technique of this retrieval, it's a basic technique where we just perform the similarity search, and based on that, we retrieve the document. Okay, so let's look into that particular technique. Now, first of all, let me give you the broader picture of this retrieval part over here. What I'm doing here, guys, let's say my user is asking query. Now this query is going through the document. Here is my document, this one. Document means like vector database. I kept like so many documents and all over there in the form of embedding. So here what I have my uh, embedding means my document. Now what I'm doing, I'm performing similarity search. Similarity search, I can write this similarity search here. SS means what? Similarity search. I'm writing in short so that I no need to write the complete and the full form and all. Okay, it's quite hectic sometimes. Then based on it, what I'm doing, I'm getting what? I'm getting my result. Okay, rank result or most similar result. So here I can write most similar result. I hope this thing is clear to all of you now. And one more thing, guys, don't forget over here. So let's say we kept the embedding. Okay, we are inside the vector database. Now, along with the embedding, guys, there will be a document also. Okay, let's say this is my document, and corresponding to this document, here is embedding. This is my document, corresponding to this, there is my embedding. Now, whenever I will perform the similarity search, this similarity search. So what I will get, I will perform the similarity search based on the embedding. This one. See, this is my query. I will perform the embedding. I will pass it over here, this one. I will perform the similarity search. Let's say this one, and this one. This is my most similar document. So with respect to this particular embedding, now I will return this original document. This original document. So don't forget about it. I hope the picture is getting clear to all of you now. Coming to the code part of it, let me explain the code within 2 to 3 minutes, and then I will come to this theory of the uh, and I will show you the architecture of the self query retrieval. That how this self query retriever is working, and the architecture is beginning from the here itself. There are a couple of other steps. Definitely, I will include it. So I've already prepared the code. Let me show you the code, guys. This is my code. I kept the architecture and all everything. So whenever you are going through with this code, you can easily understand and you can easily revise. So I have a document which I'm going to split. Okay, then I'm storing somewhere retrieval and output. Now, when we have to use this particular approach, so here I've written the particular condition. Just read this condition. I'm saying this is the most basic flow. This flow basically which I shown you, but would be very effective in the document like PDF. So whenever we are going to store anything inside the PDF like text, okay, the sequence of the information and all. I can give you the example that like books or the research paper and all which we see, or anything which we are storing inside the PDF and all, where actually there is a linearity in the data. As I was telling you, the linearity in the data, so we can make a chunks and all with respect to the data. We can keep it somewhere, and we can perform the similarity search on top of it. So just read this particular line. What I'm saying, PDF where there is a linearity in the data and no major interdependency among different part of the document. Okay, so my data is we have a linearity in the data, but there is not major dependency in between. Getting my point? So I can give you the example of the book. Let's say in the book we have 100 pages. So hardly, okay, let's say we have first page and the 50th page. So hardly this 50th page will match to the first page. It is indirectly matching, but not directly dependent. Getting my point? So in this particular situation, definitely I can use it where uh, anything I kept inside the PDF, and the linearity in the data means the sequence of the data, the text data and all. Okay, and no major dependency. Please keep this thing in your mind. Now this approach is having some issues also. So here in the issues, similarity search will filter out only top case similar chunk, as we know, right? So which is similar to the user query. Okay, but it might not be a relevant chunk. It might not be a relevant chunk means what? So whenever we are fetching the information, I think in the previous video also I have shown you in the compressor retriever that most of the chunk basically it's not at all the relevant one. Okay, so those chunk basically it was not relating with the query. So what I will do with those chunk, if I'm passing to my LLM model, in that case hardly like I will get a good answer. So this is the issue, guys, because here everything is depend on the vector search. Okay, whatever word and all is coming inside the particular sentence, it is based on that. So yes, like this problem might occur. Okay, the second thing is what, here it will give you the top k chunk only based on the word represent the query, as I was telling to you, right, without having knowledge of it dependency on the other chunk. Did you understand what I'm saying? So here I'm trying to say, let's say here I retrieve two chunks. Here's my query, this one. Now here is what? Here is my chunk. I got first chunk. Okay. Now here is my query. and there is my second chunk, this one. I think it is visible. Let me change the color. So this chunk actually, it is hardly dependent to each other. It is not at all dependent. Okay, it is not at all dependent basically. If we are going to retrieve the chunks, this particular chunk with which technique, the basic technique, okay, direct similarity search and all. So this is a problem. Now when you can use this particular technique, tell me. As I told you, whenever the data inside the PDF, the text data and all, okay, which is kept there, and there's a linearity and no major dependency. But the problem we have seen with respect to this particular approach, okay, so whatever chunk it is going to be collect, it is, first of all, it is irrelevant, and the second is it is not having the dependency. So because of that, people came up with the different techniques of this retrieval. So I'm going to discuss all those techniques. So first of all, let me show you the code over here. So here is my library. These are the library which is required: Langchain, OpenAI, TikToken, PyPDF files, GPU. So if I'm going to be load any information from the pipe from the PDF, for that this PyPDF is required. Then this OpenAI, but I kept the Gemini code as well. I'm using the OpenAI over here, but don't worry. I kept the Gemini code so that like you can run that all. You can run the Gemini code if you don't have the key of the OpenAI, because I have seen many people don't have the key because of the like credit card issues and all. So yes, I kept the both code. Now apart from this one, Langchain community, we can install this library as well. And this Langchain chroma as a vector database, we're going to use this chroma. Then what we have this like Google Gemini code. So yes, you can do one thing. You can generate the key from the like Gemini API from the Google AI Studio, okay, and then you can access this Gemini model as well, both embedding and this Gemini 1.5 Pro, 1 Pro, or maybe Vision model and all, whatever you want to load. So now guys, coming to the next part, here I am loading my OpenAI key. Then here I'm setting as an environment variable. Now there is my different statement. First is chroma, second is document, and the third one is what? OpenAI embedding. Now here I am loading my embedding model. After this one, guys, this is my data. So what I did, guys, see, I haven't loaded any PDF and all. Why? Intentionally, because I want to make a comparison between this particular approach, the basic one, and the self query approach, okay. And generally like whenever we are talking about the self query approach now, so generally we use those particular approach with the metadata and all, okay, because in the self query actually what it is doing, so query itself is going to create a schema with respect to this information. So generally what we do whenever we have this metadata and all along with the document, so we use this self query retrieval approach. And if we don't have it, guys, simply we can use the simple rag flow, right? So later on, see, once I will complete all the retrieval technique and all, so what you can do, you can use this basic rag flow. Okay, you can take one PDF, you can take one you can take this particular basic rag flow, and basically you can create a retrieval and all. Then after completing all the retrieval and all now, you can use the same data with respect to those retrieval technique as well, and then compare it and then see which one is giving you the better result. But as of now, just for the like sake of simplicity and all, I kept this data, so we can have a better like measurement and differences and all. I can calculate between these two particular approaches. Now coming to the next part. So after keeping the data, and here is the metadata. What I can do, see, here is my chroma.from document, means I'm storing my data inside my vector database. Then here is my questions, a different question, guys. So which 1994 animated movie has a rating of 8.5? Which movie feature Batman facing off against the Joker, and who directed it? Then what genre is movie The Matrix, and who directed it? Now once I will run it, guys. See here what I did. I performed the similarity search, okay, with this question one. What I'm getting these particular answers. So by default, actually, I will get four answer if I'm not going to mention any k value. So here it is, the first answer is what? So let me show you the question. Which 1994 animated movie has a rating of 8.5? Okay, so see, it is giving me this particular like content at the first place, but this content actually it is not having any basically rating, okay. And here I'm asking the question related to the rating, and this is a major drawback of this particular technique. So that is what I was telling to you. Basically you can utilize this basic reg flow, but it might mislead the information sometime. Don't worry, in the next one, here you can see it is giving me answer. The young lion princess feels and all. but this question actually it is not related to this one. This answer actually the second one it is not related to this one. Maybe we have a limited data, but yes, we can test with a huge little huge data where we have around 100 to 200 record. In that case, we can better judge. So what you can do, uh, just do one thing, guys, on my request, just create multiple more documents. Means let's say 50 to 100 document. You can easily create it from the bard or from the gpt itself, and then apply it and then see this ranking. Okay, ranking of this document. As of now, guys, here you can see I'm passing this particular question, but like whenever I'm performing similarity search, so here it is not giving me a first answer with this 80.8.5 rating. Okay, it is fine. Means this content is matching with this query because of the vector search or this similarity search and all, but this is not here. Now in the next one, here you can see it is fetching the answer and all, and yes, it is fine. Now the second question is, which movie features Batman facing off against the Joker? Who directed it? So I'm asking this particular question, and yes, here you can see the similar result. But again, I'm saying, guys, here the first result, but again it is giving me some other result as well. This one, which is not at all directly related with this particular question. Again, I'm saying we don't have much data, so we cannot judge directly. But again, like it's the same thing here, which is having a first one, and directly it is matching with the question two based on the retrieval. But again, the other one is not matching. But yes, by default, basically it will give you the four answer. So based on the ranking and the similarity search, it is generating those particular answer. So I hope this is clear to all of you. So what is the conclusion over here? So if we have this type of question where some metadata is involved, okay, where actually I have to fetch the what I have to do, tell me, where actually I have to fetch the information based on this metadata. So this particular basic rag flow actually it will not work, and it might mislead to you during giving the information and all. Okay, so better we can use the other technique if we have this type of metadata and all. So here itself, this self query comes. Now, what I did after performing this similarity search and all, here you can see I created this as a retriever, means this vector store actually I'm using as a retriever. So it will give me a like this top four document, and then directly I can pass to my LLM for the final generation. Means I'm into my last step. So here is my LLM model. Then it's my text step, just the additional method, just to showing the output in a better way. Then here is my prompt template. Then here is basically I'm creating my prompt. Okay, this one. And here is my chain, guys. So first is my retriever, which is taking a data, collecting a data. This method actually it is taking a question, then prompt, then LLM, and finally I'm structuring my output. Then what I'm doing, I'm invoking my chain, and I'm asking the question. Let's say here is my question first. So in the question first, let me show you what was there. I'm asking the question first. QUSTION question first. Now see, here is my question first. Which movie 1994 animated has a rating of 8.5? So it is telling to me the 1994 animated movie with a rating of 8.5 is a young lion princess feels his kingdom. Okay, so yes, you can check with this particular answer. What is the movie name? Young lion princess feels. Please. Okay, so young lion. Where is a young lion? Yang lawyer, yes, it is having 8.5 rating. So likewise, basically you can ask the other question as well, and definitely you can check the answers and all. Let me show you one more question to all of you. So here I'm passing this question 3, and what it is giving to me, it is giving to me my answer, and let's try to format this answer using this text step. So here I am going to keep my answer where it is, this one. So let me keep it over here inside this code shell, and then what I'm getting, I am getting my reply. So the general matrix is science fiction. It was directed by the Lana Winsky and Lily uh, Wonsky. Okay, so here you can see this Matrix movie. Who has directed this one? So a hacker simulated a rebel against the machine. It, and see, here's the director and all. Lana Wachowski and this Lily Wachowski. I think this thing is clear to all of you, how it is fetching the answer and how it is generating the response. But again, I'm saying whenever we have a metadata and all, so using this normal retrieval technique, we should use the self query retrieval because it will give you the best to best answer. Okay, the better answer. Now let's try to understand this self query retrieval, guys. So first guys, let's understand the architecture of the self-query retrieval and then we'll implement it using the Langchain. So for the architecture, I'm going to explain you over the blackboard itself. So this is the architecture of the basic flow, and here we have a few things inside the self-query retrieval. Let me explain you step by step. So let's say my query, user is asking the query. What is the main aim? Tell me, main aim of this particular query to retrieve the information. So what I can do guys, I can keep it this particular thing over the next page, and here I can explain you in a better way. See, here is my query. I'm asking my query to my database. Okay, this one. Here is my database. I can create a database using the different color. Just a second. Database. This database could be anything. And now what I'm doing here, see, just a second. So yes. Now what I will do, I will retrieve my answer. Okay. Here is my answer. Here's my response. So I can write over here, retrieve answer. Right. Now see what is happening actually. This is the direct way. Now in the self-query retrieval, actually this query actually it is being passed to the LLM. Yes, guys, true. So I will pass my query to where to the LLM, to my large language model. Now this large language model along with this query, what I will pass two more things. The first thing is prompt. Yes, guys, it is true. So the first thing what I will pass the prompt. And the second thing, it's not a second, prompt is a second, and this is the third one because we already have query. Attribute information. Okay, attribute information means metadata information. Okay, attribute information. Now this thing, I'm passing where I'm passing to my LLM. Now what I will do based on this particular information, three information: query, attribute information means at meta information, and this prompt. I will generate my structure schema. Structure schema. So this is my structure schema. Now this structure schema basically, with that actually I can what I can do, I can collect the different keywords. Okay, I can put out the different filters. Okay, so I can collect the keyword, I can get the filters and all, and then on top of it, basically I can perform the operation, or just forget about the operation. What I can do, I can fetch this particular information, this information basically which I shown you, and this information where I can pass, tell me, this particular information I can pass the keyword and the various filter and all, I can put over here to this structure schema. It is also called structure query. This one, it is also called structure query. Okay, and then we are passing to my database, and based on this one, I'm fetching the information. So there is two information. Let me repeat this particular architecture. So first, directly I'm passing this query, whatever query we have. So I'm directly passing to the database, and based on the similarity search, what I'm doing, I'm getting my answer. Okay, this one, or this one. Okay, then what I'm doing here, we have a direct way also. So in that particular way, just follow my cursor, what I'm saying over here, whatever I'm saying, just focus now. So this query I'm passing to my LLM. Okay, here is my LLM. Along with this query, I'm passing meta information, attribute information. I'm passing my prompt, whatever I want to perform using this LLM. I'm creating my schema, okay, structure schema. Then I'm like filtering out the keyword and all, okay, the different information. And then I'm passing this information to my database. And based on this particular information, okay, this keyword filters and all, like greater than, less than and all. So I'm fetching what I'm fetching the relevant answer. So this one, this self query, okay, let me explain you the name. The name is what? Self query retrieval. Okay, so let me explain you the meaning. So here we have a query which is retrieving something by itself. So this is the complete meaning of this self query retriever. I think you are getting my point. Now, once I will implement it, you will get to know. Now, one more thing we have. See, in my previous many people are saying, sir, please show me the solution and all using the CSV data. Okay, please show us the solution using the different NoSQL data. So guys, are you checking my YouTube channel? I already created so many videos on top of it. So here, if you will go and check with my e-commerce chatbot, I completely took the CSV data. Okay, if you will go and check with my MongoDB, right, this one, with the MongoDB with Pinecone, here I took my CSV data. Okay, I kept the meta information and all. Now, if you will check with my multimodal rag and all, I took the CSV data. I took the unstructured data, and then I collected it in a various way. So please check out with my YouTube video, guys, with the different the other YouTube video, the complete rag pipeline. You will get a lots of information. And don't worry, in future, again, I will be creating the dedicated video also, so that later on you can go through with it. Now, one more thing, guys, here, see, whenever we are talking about the self-query retrieval, so I was confused. I was confused with the self-query retrieval. My confusion was when I was exploring when I was exploring it and learning it. Now, let's say we have a database. Let's say we have a MongoDB database, because I work with the MongoDB, so I know about it. MongoDB. Now, MongoDB, just tell me yes or no. You can mention inside the comment section. This MongoDB, it is providing you the vector search. Okay, vector search. Along with it, you can keep the other information also inside this MongoDB, and even you can check with the Astra also. I already covered the Astra. This Astra. You can keep the you can perform the vector search. Okay, and you can keep the other data as well, right? You can keep the meta information also inside this Astra also, meta information. Now, guys, I work with the MongoDB. There I seen, so I can perform this. I can perform this vector search and all. So let's say here is my query. I can perform the vector search over there, and here is my document. Okay. Now, vector search. VS means what? Vector search, and this is my relevant document. Relevant document. Okay. Now, guys, this particular information, this relevant document, whatever I'm getting now, I can filter it out using this metadata. Yes. What I can do, I can filter it out using the metadata. I can write the different filter operation, and what I can do, this particular relevant doc, right? I'll be getting only those document which is matching, which is basically which I'm filtering out using this metadata and all. Okay, so query vector search, and here I'm performing this vector search using the document, and this is my relevant document. Metadata, my filter operation. Okay, greater than, less than, equal to, whatever, and here I'm getting my relevant document. This one. Now, guys, see, I was confused because I work with this particular schema, and here you can see this MongoDB schema, this one. So what I'm doing, I'm performing vector search, and here is my filter condition, and here is my limit number of result, how much result I want. Okay, the path of the vector means the embedding and all. So if you don't know about it, I would suggest you please go and check with my these two video. Everything, guys, will be clarified with respect to the MongoDB. This three video, guys. Just believe me. Okay. Now just focus over here. See. So I was just confused. Now my confusion was was valid, right? Because here also we are performing the filter and all with respect to this metadata. But when I closely observe to it, okay, this particular architecture, I only created this one, like taking a different references and all. So here I've seen. So everything is basically depend on the query itself. And here, guys, manually we are not performing any sort of a filter operation and all. Here, everything is being done by the query. How? Using this LLM. Because in the last stage, okay, in the last stage, we use what? We use this LLM for generating the output. But here inside this particular operation, right? In between, we are using LLM for creating this structure schema. Getting my point? And then we are filtering out the information and we are passing to the like database, and we are getting a relevant information. Maybe you are not getting it from here. So let's do one thing. Let's try to take one more example. I kept everything for you. So here, guys, this is my example, and with this particular example, maybe everything will be clarified. So let's say here, what is happening? Uh, Find document about the machine learning published after 2020. So this is my question. Now here I want to create a structure query. Okay, using what? Using this particular question. So how it will be created, guys? Tell me. So here from this particular document, first my keyword will be extracted. Not only this keyword, the surrounding keyword also with respect to this particular keyword. So inside this particular question, you can see what I have. I have machine learning published by after 2020. So this deep learning AI, actually, it is what? It is related to the machine learning. So this particular keyword also has been extracted. Now filter. Okay, filter means what? So publication date, and after what? After this 2020. So this is what? This is my filter, means greater than, less than. I can put it over here. Okay. And here is what? Here's my keyword, and based on this one I can fetch the information. And how it is happening, guys? Tell me from this query. How basically we are creating this structure schema using LLM. And now I will show you what? I will show you the practical implementation using the Langchain. Now, benefit of the structure query: so accurate search, efficient retrieval, and advanced filtering and all. So I hope this theory is clear to all of you. Now let's go back to the practical of the self query retrieval, guys. Now in this architecture, you can see we are passing the question: what are some movies about aliens made in 1980? Here is my query parser. This query parser is nothing, it's a LLM only. It is filtering out the answer, right? So it is filtering out the query. So it is writing equal to what? Year 1980, and here aliens is my search term for the performing the keyword search or this vector search and all, right? Now I hope this thing is clear. So I kept some theory point as well. You can definitely read it out just to get the information from here. User input, building a structure query, then searching the data store, and then returning the result and all. Now whenever we are talking about where we should use this particular technique, so here I written that as well. Just a second. Mm, Yes, this one, guys. So where we should use this particular technique, it is very, very effective where you have to search in a small subset of the large document. Means let's say you have a huge amount of data. Now from those particular data, you just want to get the relevant information. At that time, you can use this particular what? That particular like system, the self query retrieval. As I was telling you the same now. So previously in my basic rec flow, the like data is very small as of now. But if we are working with a huge data, so it might problem. Okay. The Whenever we are fetching the information and all, it might mislead to you, and the most of the information is like irrelevant one. So in that case, you can utilize this particular approach, because it will search based on the specific metadata, the information and all, and it will work fine. Now here, guys, let's see what all thing is required. So these are the import statement. You can go through with this particular statement. Then after this import statement, here you can see what we have. So here my data, the same data I'm using. Okay, the previous one only. Now after this data, what I'm doing, I'm creating my vector store. Okay, chroma vector store. Then here is my vector store. Then guys, now see, from here the real solution is going to be start. From Langchain, chains, query constructor, from base, we are importing this attribute information. Now, one more thing, let me show you. Once you will search about this self query retrieval Langchain, you will get the complete. You will get the complete implementation. Just search about the self query retrieval, and here, guys, you can see this is the data. Okay, I took the reference of the Langchain itself. Then here is the meta information and all. Now, guys, see, they have given you two approaches. First is the high level approach, where you no need to do anything. Just define your attribute information. Here is your document content description, means the description about your data, and here is what? Here is your LLM, and then you are calling this method from the self query retriever. They have given you one class, the self query retriever class. Okay, inside this we have a method from LLM. Now this method is doing everything for you, right? But with this particular approach, like see, hardly 5 to 7 line of code, that's it, nothing else, and you will get your retrieve document. But with this particular code, you won't be able to understand the complete approach. So what I did, I kept with you the low level approach. So with that, actually you can easily understand how this structure schema. Okay, the structure query schema is being created, and the other sort of a thing, right? So what I have this attribute information. This is my information, attribute information, like this metadata information. So first is genre. Okay, genre of the movie, what type of movie it is, drama, comedy, and all fiction. See, this is the description of it. Then the second is year. Okay, the year of the movie was released. Then the director and the rating. Okay, this is what, this is all about my meta information. So how I have to create it? I have to create it using this attribute information. Then the next thing is what, self query retriever, this class, and then chat OpenAI. Now let's see how basically we are creating the query schema. Okay, so what I'm doing here is my document content description, means brief summary of the movie. I'm just giving my content description. You can write anything in your words. Then what I have my this two classes. First is structure query output parser, and then get query constructor prompt. So as I told you, we are passing two things, three things to my LLM model. First is query, second is attribute information, and third is this prompt. Okay. Now what I'm doing, I'm creating my prompt. So see over here how we are creating a prompt. I have to create a prompt in such a way so that whatever schema is going to be created, so this should be around to this particular information, this particular information. Now see, here is what, here is my prompt. Okay, I'm calling this method get query constructor prompt. I'm passing my document description and this metadata information. And yes, after running it, guys, here you can see this is my prompt. Okay, this complete prompt. This prompt actually it is little huge. Okay, you will get lots of information inside this prompt. You can definitely read it out, right? Now guys, here you will find out once you will check with the prompt. So we have a lots of things. See, it's a few short prompt template, okay, which is containing a different information. Now here you will find out the like content. Okay, so some by default information is also there, but if you will look into that at the end of the prompt, right, just like scroll down and try to see over here this description, the name of the movie, director, and all. Okay, each and everything basically it's tried to cover over here. So this prompt is having the complete information about what, about my meta information. Okay, about this attribute information, so that only based on the query it can generate something reliable from the LLM. Now after this one, guys, see, once I got this prompt, now after this prompt, here one more module is required, that is lorg. Okay, so why this lorg is required? This lorg is required for this structure query output parser, the final output which I will get. Okay, after the LLM and all, for that this lorg is required. It's a supportive library. Now what I'm doing over here, see, here is my LLM model. I think I already created, so it is not required, and I kept the key as well. Don't worry, I will delete it after the session. Now here is what, here is my structure query output parser, and I'm calling what, I'm calling this from component. Okay, and here was what, here was my prompt, guys. So far what I have this attribute information, this summary, okay, this document description and all. Then this import statement. Okay, this one is structure query output parser, means for my final query, and this get query constructor. Okay, so here is my get query constructor prompt, basically from the particular information. Now what I have to do after this one, see guys, here is my query constructor. How I am going to construct the query? I told you we require a couple of things. First is prompt, the second is LLM, the third one is what, output parser. Okay, I will pass my query, so it is going to be execute one by one. Just look into this particular architecture and the thing will be more clear to all of you. This one, so we have query, we have LLM. Okay, now to this particular LLM we are passing attribute information, prompt, and this structure schema, and then basically we'll be getting the structure schema based on this particular query. So the same thing we are doing over here. See guys, here we are passing prompt, here is my LLM, here is my output parser, this one, and what I'm passing my query. Where is meta information and all? It is inside this particular prompt, right? Now after doing it, guys, so here I have written this dummy question. Now whatever query you can write. Okay, I just written this dummy question. Okay, and here you can see what I'm getting my prompt format, the complete format basically, right? So what I'm doing, see, here is my query, I'm passing it to my prompt format. It is formatting the complete prompt. Okay, this one based on my query and all. So this is my complete prompt. Now see, the same prompt basically I was getting over here, this one. See, this prompt is having already some sort of information and all. By default they have kept it over here. So this is what, this is my query constructor. It will give me a final query, and this is my prompt. Basically I am showing you how basically the prompt looking like after passing the query over here. Now after this one, guys, here just if you will scroll down, you will get the main code. So I'm calling this invoke, okay, based on this my main query, okay, based on my main query. Again, I'm repeating, here is what, here is my query constructor where I'm passing this prompt. Here is my LLM and output parser. Now I will invoke this thing using what, using my real query. And what I will get, I will get my final schema with respect to that particular query. And this is nothing, this is my just prompt format, okay, using this dummy question and all and everything you can check out with this particular format of the prompt. Now see, this is my structure query, guys, which I'm getting. So what are some sci-fi movie from 90s directed by Luke Besson about taxi driver? So what information it is fetching out, see over here, it is fetching out year, okay, and here you can see compare basically here you can see the comparison operator, okay, it has assigned the comparison operator as well. Attribute is director, okay, value is Luke Besson. Okay, now here you can see greater than, equal to, and, or, okay, and see attribute is what, genre, value is what, science fiction. So it is fetching the different information from the query, and it is assigning the different operations also. It is keeping the different operation as well, like equal to, greater to, equal to, greater than, less than, and, or, whatever. So that later on what we can do, we can filter out the information, okay. Later on what we can do, we can filter out the information from the database. Now I hope this thing is clear to all of you, how basically it is fetching the information from where, tell me, from this particular like from the database based on this particular query. Now what I can do, I can simply create my chain and all for the final answer. And this is my retriever, guys. So self query retriever, here is my what, here is my query constructor, this is my vector store, and here is what, here is my structure query translator. So what is this? Chroma translator. Now let me give you the a quick recap over here, because this is very much important. So query constructor will create a query like this, okay, it will fetch each and every information from the query. See over here, this is my query. Now attribute information, okay, now the other thing like this year and all, and here you can see the attribute director and all, everything, okay. So it is fetching each and every information based on this particular query. Now what it will do, so it is like interacting with the database, vector database, and finally it is going to arrange the query, means it is going to be structure the particular query, okay. So this is what, this is my retriever, and whatever information I will get based on this particular retriever, I will pass to my model. Now let me show you the final chain. So here I'm going to be retrieve this particular information, sorry, I'm going to be I'm going to be invoke this particular retriever. What a movie after 1919 but before 2020 2005, that all about toys and preferably in is animated. So this is the movie, like toy come alive and have a blast doing, and here's the metadata and all, everything is providing to me. And this information, guys, it's a relevant information. It is not like the previous information which is giving to me a so many things, so many answer. No, it's not like that. It is giving me a precise information. Now yes, we are able to retrieve the data, retrieve the precise information based on what, based on this like metadata and all, okay, based on this self query retriever. Where is my query constructor, vector store, okay, which is helping us to retrieve the necessary information, and then it is arranging in a final one. Now it's my LLM chain, so it's my prompt, okay, this is my chain where I'm having my retriever, question, prompt, LLM, and str output. I'm passing the like same question, and here you can see the answer, guys. If I'm asking this question, tell me about the movie which has rating more than 7, so it is giving me all the movie which is having rating more than 7. Now if I'm going to ask the same question, this same question to my the previous one, let me show you the previous one, okay. So here where it is above the self query itself, and I'm going to ask the same question, and you will find out the differences now. So what is the actual differences between this one? So what I'm doing, I'm just going to paste this question. Now let me copy it over here, let me paste it down, and instead of this one, I'm keeping this particular question, and then finally I'll be getting my text reply. So now I will print what? I'll print my text reply, and here is my reply, guys. See, it is just giving me hardly the movie name, not the complete information. And see, guys, how much difference there is between the output. So that's why I was saying this self-query retriever is way more powerful. Definitely you can use it if you have metadata inside, where metadata inside your data. Okay, so fine, I hope this is it. This is like enough for this particular video. In the next video I'll be coming up with a different retrieval technique. Until, thank you, bye bye guys, take care, have a great day.